about the perpendicular bisector theorem and the angle bisector theorem. Okay, and I'm going to let you copy these down. Perpendicular bisector theorem says if a point is on the perpendicular bisector of a segment, then it's equal distance from the endpoints of the segment. I'll let you copy this, and then we'll talk about what it means.
Is this 5-2?
Please. So what this is saying is that this red line is a perpendicular bisector to the blue segment, segment AB. So that means that this angle is a right angle, because those lines are perpendicular, and it means it cuts this blue segment into two equal segments, making that point the what? The midpoint. Very good. That's called the midpoint. We'll label it M to represent midpoint. Okay? So if that red line is a perpendicular bisector to the blue line, then it doesn't matter where you pick a point on the red line. If I pick this point right here, then the distance from that point to A and from that point to B will be equal. Okay? Doesn't matter which point you pick on that perpendicular bisector, it will be equal distance from each endpoint. Now, if you look at that bigger picture, what shape is that?
Triangle.
A triangle. What kind of a triangle?
Isosceles.
Isosceles, because it has two sides equal. Okay? Two sides equal. All right? Now I can move that point wherever I want it. I can move this point, sorry, I didn't get, let's try again. I move that point down to here if I want. And so this distance is going to equal this distance. Okay? Those distances are going to be equal. Doesn't matter which point you pick. If it's on the perpendicular bisector, it's going to be equal distance from the endpoints. Okay? Any questions on that? All right, the next one then is the converse of it. I'll let you. So now what this one's saying, quiet please. This one's saying if the point is equal distance from the endpoints, so they're saying if I have this point right here that's equal distance from the endpoints of this segment, the blue segment, then that has to be on the perpendicular bisector. Whoops, sorry. That has to be on this perpendicular bisector. Okay? It has to be on the perpendicular bisector. So it's just the converse of the other one. So it just switches it around. All right? Okay, let's move on.
So,
I'm sorry, we're done?
I don't know how you even do that. You gotta explain that one more time.
Oh, okay.
I'm not understanding what you were talking about.
Okay, what I said is the first theorem tells us that if a point is on the perpendicular bisector, then it's equal distance from the endpoint. So if this red line is the perpendicular bisector, then any point on that line is going to be equal distance from the endpoints of this blue segment. Okay? The converse of that is just switching it around. It's saying if this point is equal distance from the endpoints, if the distance from here to this endpoint is the same as the distance from here to this one, then this point has to be on, it has to be on this perpendicular bisector, which is this red line. Okay? It's just switching it around, what you started with and what you end up with. That's what the converse does. All right, so the next one, we have two more theorems here. But before we can get to them, we have to understand this. The distance from a point to a line is the length of the perpendicular to the line. So copy that down, and I'll draw a picture explaining what I'm talking about. distance from a point to a line is the length of the perpendicular to the line. Oh, I'm sorry.
Whoa.
Let's come back to this. Before we expose that, hope I wasn't recording all the time before.
No.
If I have this line and I have a point not on the line, right there, okay? Let me make it a little bigger. All right? If I gave you a ruler and said, hey, let's measure the distance from this. Some people are going to bring this up here and put that on there like that, and they're going to say, oh, that's about 3. Okay? Some people would do that. And others will come up here and say, oh, no, you've got to measure to there. And they say, oh, that's about 6. And someone else would come up and they'd measure, and they say, no, you got to go to this end, and they'd say it's about 4. Okay? So because, it's just like, John, follow along with me. It's just like simplifying expressions. We have order of operations, right? If we didn't have rules, what would happen with our order of operations?
One word.
What would happen? Let's try to get serious for a minute. I'm tired of the horse
We
around.
didn't get the right answer.
We would get different answers, right? Some of them would be right and some would be wrong. But we get different answers. If I had 5, let's actually choose a marker. 5 squared minus 2 times 3 plus 4, and I just said, hey, ignore all the rules and go solve that, we might get 10 different answers.
You could.
Okay? So we have to have rules so that we always get the same result from the same expression. All right? And what this rule is saying is that to measure the distance from a point to a line, it's going to be the distance from the perpendicular to that line. And so what that means is, if I took my protractor, no, you don't. I just want to explain something. So if I took my protractor and put this on the line,
Okay. Come on, there's gotta be something they can suspend. John.
You can bring a gun to
Suspend John.
Take me with you, John.
John, I love you. Good luck, bud.
okay, now, hey guys, hey, stop talking, watch what we're doing here. What I've done is I put my protractor on the line so that it passes through, oh shucks, let me draw it. So that the 90 passes through the point, okay? So that the 90 passes through the point. Now, what I want to do now is line my ruler up on that. And measure the distance from that point to the line. And so that distance is, can anybody see it?
2.5.
2.5. I can live with that. That's really close. So the distance from the point to the line is 2.5. Now that I have this perpendicular, I can move my protractor out of the way. This line here is now perpendicular to the other, the point is on the line that's perpendicular to the other line. Okay? What we're going to just talk about in just a minute has us measuring the distance from a point to a line. You don't actually have to measure it. You just have to understand that that distance has to be perpendicular. So if you see this, told this is x, then that means the distance from the point to the line is x. Okay? That's what that means. All right, let me pause for a minute while I clean this up. Okay, so the first one says, the angle bisector theorem. I'll read it, and I'll pause so you can copy it down, and then we'll talk about it. We'll draw a picture that represents it. It says, the angle bisector theorem says if a point is on the bisector of an angle, then the point is equal distance from the sides of the angle. All right. So we have here in the blue, we have an angle. And the red line represents the bisector of that blue angle. Okay? That means this distance here, or that measurement there, is the same as that measurement there. Okay? So, what we want to realize is that since this is the angle bisector, we can pick any point. We can pick any point we want on that bisector. So if I pick this point right here, if I pick that point right there, then it means the distance from that point to one side of the angle is equal to the distance from that point to the other side of the angle. So, and remember we just talked about those have to be perpendicular. A point to a line has to be perpendicular. So if I got my protractor out, I could make sure it's perpendicular. We'll just do this and do this and agree that means it has to be perpendicular. So that means this distance here has to equal that distance there. I'll use 2 markers. Okay? Those distances have to be equal. So if I'm told that this distance here is 3x minus 7, and I'm told that this distance over here is x plus 5, okay, then we can find the length, we can find the value of x, and we can find the length. So what equation would I write? Okay, 3x minus 7 is equal to x plus 5. So if I subtract x from both sides, 2x minus 7 is equal to 5. Did I go too quick on that? What would I do next?
Add the 7.
Add 7 to both sides. And so I get 2x is equal to 12. And so divide by 2, x is equal to 6. So I now know what x is. Can I find the length or the distance from the point to the line, or to the angle, I mean? How would I do it? Okay, I'd put 6 in where the x was. So 3 times 6 minus 7 is 18 minus 7, which is 11. Or if I tried it over here, I get 6 plus 5, which is 11. So the distance from that point to the angle is 11. Okay? That is what the angle bisector theorem is saying. Now the next one is the converse of that. And remember, converse just switches it around. So the converse is saying if I already know this point is equal distance from the rays, then that means the point is on the angle bisector. And it looks like that. So our assignment today, lesson 5-2. Many of these are very quick. Yeah, I did one just a moment ago. Okay, but we'll wander around and help you out if you get hung up. But you're going to be practicing concepts like this, setting them equal to each other. And then on the
I might skip AC.
Perpendicular bisectors, these are the segments that are equal to each other.
Or
Okay.
show up, get counted.
So those are the problems you're gonna work on.